I want to show you how to analyze data generated from randomized complete block design (RCBD) in R statistical software. In case you are new to RCBD, this is how this experimental design looks like in the field. We have blocks here. For instance, here we have 3 blocks and we have 4 treatments. In each block, we have 4 treatments. All these treatments are here in all the blocks. Therefore, blocks are said to be complete. And blocks are randomized. As you can see, arrangement of treatments here is different from block 2 and 3. This is because of randomization. Therefore, in RCPD, blocks are randomized and complete. And that's where the name came from, randomized complete block design. Now let's move to R and analyze data. Is to load your data into R, and my data is here. I saved it as data.csv. Therefore, I'm going to use read.csv function to load it into R and call it data. Let me run that. Good. My data has come here in the environment. You can see it. The next thing is to view the structure of the data using str function. And here you can see we have these columns: location, block, genotype, and yield. And you can see their formats here. And we can open this data to view it from in our data in the data frame. This is location, block, genotype, and yield. You can see it here. And therefore, I would like this character to be factors because location, block, and genotype are explanatory variable, and yield is the response variable. Explanatory variable is a source of variance that I would like it to be factors. I use as dot factor function to convert location, block, and genotype columns into factors. We run that, and that. So if I just see the structure again of my data, I will get that this function has been executed. You can see here location, block, and genotype, they are factors, and we are good. Now next thing to do is to fit the model. First, we are going to fit a fixed effect model, and we are going to use a LM function standing for linear model. Yield is our response variable. We first write yield, our response variable. Then next, you just put this tilde. This sign is called tilde, stands for assigning this. Yield is explained by first write the main effects. Main effects are block, location, and genotype. Then you will write the interaction, genotype by location. Therefore, this yield is explained by block, location, genotype, and genotype by location interaction. Then you specify your data and run. We get our model. This model can also be written like that, like this one. So by writing location times genotype, R will understand that it's location plus genotype plus location times genotype interaction. And it's the same model. So let's view our ANOVA of this fixed effect model. This is ANOVA. We have seen it here. That's how it's done. Now let's fit mixed model with the fixed and random effects. We are going to use LME4 package. So we load it into the library, and we are going to use LMER function of LME4, and we're going to use LMER function of LME4, and we call our model mod1. We write our model as we wrote in the fixed model, but now genotype are random. We put 1 here and this sign here, and this interaction genotype by location is random. We put this sign 1 and this sign here to make them random. But block and location, these are fixed effects. We run that. If we want to view ANOVA, it's going to give us ANOVA of fixed effects alone, which is block and location. Let's run that. You can see it has given us ANOVA of a block and location. But if you want to see the variance component of random factors, you just run summary and you are going to get it's here. You're going to get the variance component of genotype per location interaction and genotype and also residue, because the residue is always random. And these are the variance components. Maybe you may need to do mean separation like LSD. We use agricoli, load agricoli into the library, and then we are going to use lsd.test function of agricoli and call our work as LSD, and we are going to do LSD test on our model which we constructed, and we are going to factor a genotype. So we are going to run that. We run that, and we just view this LSD, just print it by just running that. You can see here we have our groups here down in the console. If you want to save these groups in our in a document, you use capture.output, then put LSD here, this LSD which we run, then you name the file the way it's going to be called. But now you have to write it .doc because we want it as a document. We run, it's here. So if I go back to the folder, it's here. You can open it using Word, and then you are going to view your groups that are separated by LSD here. I hope this was helpful. Thank you very much.